Hello everyone, and welcome to this lecture in P8105, a course on data science. This is the third in a collection of 3 videos on building blocks, things like code and project organization, reproducibility, and version control. This video will focus on version control using Git and Github. I'll start by giving an introduction using slides, and afterwards I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful. To get the most out of this, I encourage you to try to code along with me. All this material is available at p8105.com. There are links in the description below. Fantastic, let's get started. Okay, I'm going to get started by trying to explain a little bit about what Git is and what GitHub is and why you might use these both when you're doing your data science projects. I want to start out by acknowledging that Git is awesome. It's a great tool. It's one of the default tools that gets used across data science in industry and in academia and in a variety of other domains. It is really fantastic. And I'm stressing that because it is also kind of a pain to use. It can be, especially when you are first learning what Git is and why you would use it. It can be confusing why you would use Git in the first place. It can be unclear how you're going to use Git. Sometimes it breaks in ways that you're not really clear about. So I want to acknowledge both of those things up front. And you might be wondering, well, if it's so bad, why are you going to use it? As I said, it's also fantastic. And generally speaking, the good stuff about Git outweighs the bad stuff about Git. And that's why it has become a really common tool for data scientists to use. But I also, I always want to be clear, especially when you're getting started with Git, that there is some bad. And a lot of that has to do with the learning curve, figuring out how you're going to use Git and why you're going to use Git. So then you might ask yourself, well, what is Git? And the first place that I'm going to start explaining this is through a couple of analogies. Git is kind of like a version of Google Docs in that you can share things, or Dropbox in the fact that you can sort of make changes across multiple machines and collaborate through something like this, something that exists in the cloud. And it's also kind of like track changes in the sense that as you make updates, those changes get sort of followed through time. And the goal of all of this is to avoid something like a drafts folder with 50 different versions of the same thing, all of them with unclear who has made edits and what they have made edits to and when they have made edits and why they have made edits. You really want to avoid that as much as possible. Now you might be saying that that's I guess maybe a useful analogy, but it still doesn't really explain what's going on. So I'm gonna try to explain in a little bit more detail. Git is software that lives on your computer, and when you initialize a Git repository, essentially when you tell Git to keep an eye on a particular folder on your machine, Git will watch that repository for changes that are being made. When you make some changes, it's going to ask or prompt you to describe why you have made those changes. And then it will remember both what changes you made, what past versions look like. It will recall the messages that you've given it to say why you made some change at a particular time. If you are working with others, if you are working with people on the same project, it will keep an eye out for conflicts. And what I mean by conflicts are when 2 people have made edits to the exact same line of the exact same file. And if you have made some conflict, it's going to force you to resolve them. It's going to say you can't have 2 versions. You need to pick one or the other or merge them somehow. It also, in the same way as something like Dropbox, allows multiple people to contribute to the same repository, and everyone all at once will sort of have this same process in mind. Now, this turns out to be exceptionally useful because you can both keep track of old versions, you can understand what a development process was, you can see what was changed and see in words why those changes were made, and you can collaborate in a way that keeps everybody using the same workflow so that if I and somebody else are working on a document, I can both see what that person has done and also try to understand why that person has done the thing that they have done. Now, that's all relevant for Git, but you'll often, and I'd say the vast majority of the time, use Git in conjunction with something like GitHub. So as a piece of software on your computer, even if you don't collaborate with anyone, and even if you never share anything online, Git will live on your computer, and it will keep track of the changes that you make in some folder, in some repository, and it will both follow those changes through time. It will ask you to give messages about why you're making some changes, and all of that lives on your computer. To get some advantage, to be able to both share the projects that you're working on more broadly and to collaborate in a way that's relatively straightforward, you're often going to use GitHub. And GitHub is sort of like Dropbox in the sense that it is a cloud storage system. It allows you to put things from Git repositories onto that platform. You can access them through the web. You can also access them by pulling changes, by getting changes from GitHub onto your machine. And so again, I think the best analogy here is that GitHub is sort of like Dropbox. It's the part that keeps track of what you're doing and transmits it back and forth to the web. Now, GitHub, it turns out, has become a really broadly used platform for disseminating work. So you can, in your repository, write reports, and then if you want somebody else to be able to access those, you can put them in a public GitHub repository and anybody can access those things. You can host websites. It is possible to download R packages from GitHub, and many people, as they are developing R packages, will put them on GitHub so that other people can use them. And so GitHub is sort of simultaneously like Dropbox as a way to sort of collaborate and put things in the cloud, while also being a platform for dissemination, a very common platform for dissemination. It looks an awful lot like this, and this schematic is in some way similar to what you would see if you were working with Dropbox, with a little bit of difference. So again, you are going to have a folder called a repository. This will be you, and this is your computer. You're going to make some work and you're going to do some changes, and then at some point you will want those changes to be stored on the GitHub servers. And if somebody else is collaborating on that same project, then they're going to want to be able to get those changes as well. Now, I'm sort of saying here, you've got your repo and they've got their repo, and there's a central remote repository, and all of these are versions of the same directory, of the same project folder. And the arrows indicate that you can put things online and others can put things online, and you can retrieve things from online and others can retrieve things from online. One of the things that differentiates GitHub from Dropbox is that Dropbox will usually make these arrows invisible to you. When you make some changes, it will automatically go to the Dropbox servers. Git and GitHub are both a little bit crankier than that. They're not going to do anything until you specifically tell. And so you can sit and make a bunch of changes here, but until you tell Git or GitHub to take these changes and put them on the GitHub servers, they're not going to be put there until you do something actively. And in the same way, if your collaborator puts something online, until you tell Git to go to that server and bring them back, then you're not going to see any of those changes. Now, there's also off to the side here a web interface, meaning that you can put things online and others can put things online, and you don't have to work within Git or GitHub to see those changes. You can go to github.com and sort of see what's been going on. And that web interface turns out to be really, really helpful, both so that people can see the work that you're disseminating, and also because it makes it easy to keep track of those changes over time. I've mentioned quite a bit that RStudio is one of the reasons that R is as useful as it is for doing data science. And RStudio, as an integrated development environment, is trying to make it easy for you to do things that you should be doing. And in general, Git is something that you should be doing. Git and GitHub, using those to manage your projects is one of the best practices that you can get into at this time. And so RStudio is going to try to make that easy for you. We have discussed in past videos, past lectures, what R projects do. We haven't sort of taken advantage of everything that those R projects do, but it turns out that they play very nicely with Git and with GitHub. And so using RStudio and R projects are going to make it easier, not necessarily easy, especially at the outset, but easier to use Git and to keep track of everything that you're doing. So the goal, again, is in an overall workflow to have a project with everything, a folder with everything relevant for a project. Now we're going to be thinking about using Git to keep track of changes to that project over time, and we're going to manage that entire process inside of RStudio. You'll often hear when people are talking about Git, about a Git client. In the same way that R allows you to type commands and then execute them, Git will allow you to type commands and control Git's behavior in that way, using something like a command line tool. I find, and many others do as well, that for a lot of things, using a Git client, a graphical user interface, something that you can look at and see, is an easier and more intuitive way to interact with Git. And so one of the things that makes this possible is to use a Git client, that user interface, and RStudio has one of those user interfaces built in. So there will be, and we'll see in the screencast in a couple of moments, the RStudio Git client that is going to allow us to do the majority of the things that we need to do with Git, all within the RStudio integrated development environment, the IDE. It's maybe helpful to sort of think of the analogy that the Git client sort of interacts with Git in the same way that RStudio interacts with R. The actual software in some way that lives on your machine, the thing that does R and the thing that does Git are those bits of software. But RStudio makes working with R easier, and a Git client makes working with Git easier. I mentioned a moment ago that one of the things you're going to want to do is have a workflow. And I find an established workflow that is consistent across projects makes it easier for me to figure out what I'm doing, to make sure that everything is in the right place, that I understand where things are going to be. Having a workflow means that I can focus on doing data science without wondering where I have left the relevant files, where the data are, and things like this. So the workflow that I use, and this is pretty consistent across a wide range of projects, is to create a GitHub repository, have a Git repository, a local directory on my computer that connects that repository to GitHub, and then inside of that repository, inside of that directory on my computer, I'm going to do the usual kind of data science development that I would do. I'm going to conduct analyses, I'm going to write reports, I'm going to do the work of doing data science. Now I say here, you're going to do stuff in a Git repository, and again, it is the usual things that you're going to do. And what differentiates doing data science in some folder and doing data science in a Git repository is that process of periodically checking in, making some changes, and then telling Git the kinds of changes you're going to make. So once you've done some amount of work, and how much work counts as a reasonable amount of work sort of differentiates from person to person or differs from person to person. But once you've done some amount of work, you're going to commit the changes. And commit here is a sort of Git vocabulary word that you're going to become familiar with. It is something like a fancy save. It's saying that there is some collection of changes to a file or a collection of files. All of those things are now things that I want to not just update, but to commit to Git's memory, to say this is a new version of the things that I have worked on. And when you do that commit, Git will ask you what has happened between now and the last time you made this commit. So you'll write a short description. Brevity really helps here. A short description that says, this is what changed from my last version. And you sort of put down these milestones every so often so that you can keep track of what happened one commit ago or two or three. And then periodically, again, since all of this is happening in a Git repository on your computer, periodically you'll want to make sure that those changes get transmitted to GitHub servers, get transmitted to the cloud. And to do that, you'll commit first and then push your changes to GitHub. And those words, commit and push, are sort of standard Git vocabulary. And this is a sign you should sort of remember. If there's a fire, commit all your changes, push everything to GitHub, and then you don't have to worry about it. It's all in the cloud. Now, again, I've sort of touched on these a couple of times and I want to reiterate them. Some of the things that are nice about using Git and GitHub is that you can go back and see what has happened earlier in some development pipeline. You can both see when a decision was made, and you can also go back and say, I actually don't want that to be gone forever. I want to revert to a previous commit. I want to go back and see the last time that something actually worked. Especially when you are working with a collaborator and keeping in mind that often that collaborator is you from the past. If you can scan those commit messages, then without having to dig into each file one at a time and see what's happened over time, you can just sort of skim the commit messages and say, all right, well, in this commit, they imported the data and they did some cleaning, and here's a new commit that was focused mostly on this kind of an analysis, and here's a commit that did some of this other stuff. You can track what happened through time quickly and easily by scanning commit messages. That also works when you are talking about working with other collaborators. Again, maybe that's other people, maybe that's you. You have some understanding of what has happened over time and also when it happened and why it happened. And then this last bullet point, I think, is more helpful than you think it is. If two people are doing something, they're changing the same thing at the same time, that's not going to last very long. Git is going to be very clear and very forceful. It's going to stop you and say, you have to resolve this conflict between this version and another version. You have to resolve this before you can be allowed to move forward. Version, or sort of these conflicts between versions, come up pretty often. You probably see them in things like Dropbox when you see, I have this conflicted copy with that conflicted copy. They come up in a variety of cases. And in Git, like I say, there's sort of, Git is a slightly crankier version of something like Dropbox. It's not just going to say, well, these are in conflict, continue on. It's going to say, these are in conflict, you have to fix them. And that, I think, is actually a good thing. Now, the downside to all of this is that it can seem like a lot of overhead, both to learn what Git is and how it works, and especially when you are installing Git for the very first time and connecting Git in RStudio to GitHub online. That installation process can be really challenging. Over time, I think you'll find that the process of working occasionally or working for a bit and then occasionally committing and pushing, it sort of fades into the background and it becomes a normal part of your routine. That's not so bad, but at the beginning it takes some time to get into that habit. I've mentioned that resolving conflicts is a helpful thing to do. I don't want to gloss over the fact that resolving conflicts can be a bit of a pain when it feels like Git is yelling at you to fix a conflict and it's unclear what the right thing to do is. Very often you have to take a step back and make sure that you and whoever else is working on something understand what's going on and find a way forward from that. And so that can be a bit of a messy process. And then I think this is in some ways a con, maybe. It requires that a lot of the people on a project are using the same development pipeline, the same software. People have sort of all gone in together on this idea that you're going to be using Git and GitHub to collaborate on some project. And that works better in some environments than it does in others. As I say, it's pretty standard among data scientists, but not everybody that you might collaborate will work in this way. There's some useful vocabulary. I've said some of this already. Repository is a way of describing a directory that Git is keeping an eye on. Committing is this version of fancy saving. Every now and then after you have made some edits to files, a file or some files, you'll say, that's enough. I want to make sure that I understand what I just did and why, so you'll do a commit. You can both push to GitHub and to get the changes that you or others have made. You can pull information from GitHub. Again, that's not going to happen in the background, and you do have to be deliberate about it. There's some other vocabulary that if you spend much time at all working with Git and GitHub, you'll come across things like branching and merging branches. You can clone repositories, you can fork repositories. We're not going to get into all of that. I think the first three here, having a repository, committing, and then getting used to pushing and pulling from GitHub is more than enough for right now. But I wanted you to be aware that at the very least, those are words that you might run into as you start seeing information about Git and GitHub online. There are some other things that I am not going to cover in addition to branching and merging and cloning and forking and things like this. GitHub as a web interface does have a variety of useful features. You can follow people on GitHub and see what kinds of things they're doing. You can watch or star particular repositories. You can send messages. Issue tracking, it turns out, is a really useful way to collaborate with, to say, this thing needs to get fixed. You can submit issues, other people can read those issues, there can be an ongoing dialogue in public so that everybody is available to understand and recognize what that process looks like. We're not going to spend a lot of time talking about much of that either. Again, we're really going to try to focus on getting used to Git repositories, committing, and then interacting with GitHub. Now, there's a last point that I do want to be very careful about stressing, and that has to do with confidentiality. GitHub, in the same way that Dropbox is on the cloud, GitHub is on the cloud, and it is public. And even if you make your Git repository private, your GitHub repository private, so that not just anyone can view it, GitHub is a company, and you do have to be very concerned about inadvertently sharing patient identifiable data. And so be careful about identifiable data in a Git repository. Be careful about inadvertently saving versions of patient identifiable data in the background and somehow putting that on Git. You can take steps to avoid this, and it is something that you should be aware of but not overly concerned about, but it is something you should be aware of. Okay, and so with that, I'm going to end the screen, or I'm going to end this bit of slide, and we're going to do a screencast looking at how you're going to use Git in the context of RStudio and our projects. All right, fantastic. What we're going to do now is try to get some experience using Git and GitHub for doing especially work for data science with R, but we're going to focus in this part, in this screencast, mostly on the pieces that have to do with Git and GitHub and less on the pieces that have to do with R and R development and other kinds of data science. I'm going to not spend an awful lot of time talking about Git installation. That is and can be sort of a tricky process. What I am going to do instead is refer to a helpful book, Happy Git with R. This is a book by Jenny Bryan. Jenny Bryan is a data scientist who is currently at RStudio and spends an awful lot of time doing useful things for workflow development, for process development. And her book here, Happy Git and GitHub, especially for people who are using R, is very helpful when you are getting up and running with Git for the first time. So installation here, I think, although it looks like long chapters, there are a few sort of quick bits of advice. They're not super long. I encourage you to work through these to make sure that you can install Git and connect it to Git and GitHub. What I'm going to spend more time on is assuming you have created a GitHub account and have installed Git onto your machine and have done some work to make sure that those two things are connected. What is the workflow that I'm going to recommend that we use for working with GitHub to do data science in R and in RStudio? And so what I'm going to do to get started to walk through that workflow is actually navigate to GitHub. And I've logged in here. So what you're seeing is the collection of updates about either repositories that I follow or folks whose repositories I'm interested in. You can navigate to your profile. This is always sort of a weird thing to do, but and there's me. It keeps track of some of the repositories that I have. If I want a full list of repositories, it's here. It sort of keeps track of when I've been making commits. And this side of things on Git and GitHub, I think, can be helpful if you want to sort of understand what you're working on, if you want to follow people or see who's following you, if you want to get a sense of who's making changes and in what way. Again, this GitHub platform is very useful for that. But what I'm going to do is look for a button that looks like this. Here it's under New. You'll see buttons like this in a variety of cases. And what this says is I want to create a new repository. So here it is, the page for creating a new repository. I'm going to own this, and I'm going to call this example repo. Let's keep it short. And I'm not going to give it a description now. I am going to make it public so that everybody has access to this, and I am going to initialize this repository with a README. That's generally speaking something that I recommend, and that's pretty much it for now. I'm going to create this repository. It's going to take a moment, and it shows, sure enough, here is a GitHub page that's showing the README. It's called example repo. It doesn't have an awful lot of information. It sort of by default has made one initial commit that includes this README file, but there's not a lot going on. Now, again, what I'm looking at is a repository that exists on GitHub, and to work with this, I'm really going to want this repository to be mirrored on my machine. And so what I'm going to do is click on this little code button, and it's going to say there are a couple of options you can download, you can open with GitHub Desktop. What I'm going to do is click this button that copies everything to that copies this address to the clipboard. Okay. Now I'm going to open up RStudio, and I'm going to create through RStudio a local directory, a local Git repository that is connected to that Git repository on GitHub. Right? So again, the process that I've used is to create a Git repository on GitHub. It exists on the cloud, but not on my machine. And now through RStudio, I'm going to create a local version of that repository so that I can do the kinds of R development that I want to do here using RStudio and connect that with a repository that exists that exists on GitHub servers. So I'm going to go to File, New Project. Again, we're going to do a lot of this in the context of an R project. And rather than a new directory or an existing directory, I'm going to come down here to version control. What I'm interested in is cloning a project from a Git repository. and I'm going to give it that repository URL. It exists here under GitHub, Jeff Goldsmith example repo.git. That's what I copy and pasted from the GitHub website, and I'm going to put this, you can put it anywhere on your machine. What I'm going to do for now, just so that everything is transparent, is put it on my desktop. The project directory name is going to mirror what exists here. You can change that. I really discourage you from doing it, but you can if you want to. And now I'm going to create this project, and it's going to sort of restart. And what we're seeing now looks an awful lot like our projects that we have seen in the past. If I go to my desktop, get this over here, I have a directory here, example repo. It has that README that was created on GitHub. And it's got this RProject file, and I can sort of navigate all of these things here. Okay, so what I've got now is an R project. Everything that I would like to have about an R project exists, but I've got one extra thing that's happening, and that's that Git, behind the scenes in a way that is apparent in some ways, but often not as apparent as you might imagine, Git is now watching this directory. And what I'm going to be able to do is make some edits, make some changes, and then tell Git to keep track of those changes in real time. Now, I say this isn't always really visually obvious that Git is doing this, but there are a couple of subtle changes. And the first thing that I'm going to draw your attention to is a file listed here under Files. It doesn't seem to appear here, but that is for reasons that your operating system, the Mac operating system, doesn't display files that begin with a . And this .git ignore has a collection of things that Git is not going to keep track of. It's not going to keep track of a .r history file in case R is saving my history. It's not going to keep track of .r data in case I have imported data and not turned that off. So Git is going to ignore each of those files, and that's pretty much it. Now, generally speaking, you're not going to make a whole lot of edits to Git ignore, and we're not going to worry so much about that for now, but it is one of the things that happens when you create a Git repository as an R project through RStudio, so I wanted to point it out. The next thing that happens is that in addition to the environment pane that we've seen in the past, there is a new tab here for Git. And this Git tab is going to be the bare bones, the stripped down Git client that is built into RStudio. And so here it's saying there are two things, status question marks here. We don't really know anything that's happening, but it's listing two files that have been created since the last Git commit. That first Git commit introduced the README. When I created this as an R project, RStudio added the example repro.rproject file, and it added the .git ignore file. Both of these have not been committed. They exist, but they haven't been saved in the way that a commit does. And to do that, to make sure that these are now committed, I'm going to click both of these and the commit dialog box, and it's going to say, okay, here's what's changed. These green lines indicate that these have been added to this file, and it's going to ask for a commit message. And I'm going to call this initial commit, where the message is going to be initial commit R project infrastructure. All right, this is just the git ignore file and the R project thing. So I'm going to commit, and it's going to give me some information that, generally speaking, you can ignore. And I'm going to close that window. And again, now not a lot has happened. My Git client is empty. There are no new files. There's nothing happening, and I don't really have to worry, right? I'm just going to sort of say, wonderful. I have made a commit. I have put these things in here. Good work. Way to go, Jeff. I'm doing a good job. All right. What I'm going to do next is, again, I don't want to spend an awful lot of time thinking about R or R Markdown or data science. We have spent some time looking at R Markdown, and mostly what I'm going to do next is revisit some template files so that I can get used to this process of committing as I make some change. So what I'm going to do next, I'm going to go back to my web browser, and I'm going to open a new page, and I'm going to go to the course website, p8105.com, and I'm going to navigate under topics. We're looking at the first collection, building blocks, and I'm going to navigate to Git and GitHub. And I'm going to scroll down a little bit and get to a couple of template files. The first of these is an R Markdown template that we looked at in Writing with Data. It's just a pretty straightforward R Markdown file. I'm going to download that. And once I've downloaded that, I'll go to my desktop. Here it is, template.rmarkdown. I'll drag it into my Git repository. And then over here in RStudio, I can open template.rmarkdown. And again, this is the simple document that we had seen previously that has a little bit of text formatting that samples from a normal distribution and computes the sample, or computes the length of that sample, and then does some inline R, right? A quick template. There's not a lot going on here, but it gives you some idea about what an R Markdown document looks like. Now I'm going to knit this. It's going to create both. It's going to create the HTML output. Looks fantastic. It's got the information from the YAML header. It's got sections. It's got text. It's got all the stuff that I would like it to have. And now I'm going to say that's enough work. I have done some things. I'm going to go ahead and tell Git that this is something that I want to commit. So here I've got a template R markdown file plus HTML output, and I'm going to commit that. Now, this might seem a little bit tedious, but I'm going to do a very similar thing. I'm going to download another template R markdown file. I'm going to walk through that process again, just to be clear about how this works. So I'm going to take the basic plots R markdown. I'm going to put it into my example repository, and in RStudio, I can see that R markdown basic plots. And I'll take a second to look at this. So here, this template's from 2019, but this is basic plots. I'm the author. It's going to output an HTML document. And the goal here is to do some things that we have seen in the past. I'm going to generate a plot data frame. That data frame is going to consist of both X and Y. X is going to come from a normal distribution, and Y is going to be 1 plus 2 times X. And then I'm going to create a histogram of the X variable, and I'm going to create a scatter plot of Y versus X using things that we have seen in the past. Again, the goal here is not to spend a lot of time dwelling on R Markdown or on Tibbles or on ggplot or whatever. The goal here is to see what happens as I add files and as I edit files and I do other things like this. So again, I'm going to knit this. And after I've knitted this, I'm going to come over here to the Git panel, and I am going to commit both of these two things. You can scan through and see what's changed. Here it's a new file. Everything's in green. Everything is new. And I'm going to create a commit message here, add plot R markdown file and HTML. So let's commit that. Great. Man, everything is just really going pretty smoothly. I'm going to do one other thing. Instead of adding something here, one of the things that I'm going to do is edit a file that already exists. And so I have this README file that was automatically generated because I clicked that little box on GitHub. This README file was automatically generated. And here I'm going to say this is a quick first Git and GitHub repo as an example for P8105. Okay, and I'm going to save this rather than looking at a preview. I'm just going to save this, and I'm going to click commit. Let's take a look here. So one thing that's happened is instead of having this that ends right here, I've created a new line. We've got a new character at the end. It goes from line 1 to line 2, and it sort of says, here's what the old file looked like, here's what the new file looked like. So here, let's update README with some basic info. All right, now I've done a fair bit of things so far. I've been doing a little bit of, at least locally, adding files, editing those files, committing those files, and all of that, I think, has changed what exists here, right? So I can take a look. Everything, the changes that I made to the README file exist. I've got the basic plots HTML and RMD and the template HTML and RMD. All of that bit, I think, is going relatively smoothly. But if I go back to my web browser and I take a look at the page that goes along with this repository, I'm going to refresh. Nothing's happened, right? As far as GitHub is concerned, the last thing that happened was that initial commit, and that was 11 minutes ago. A lot's happened in the last 11 minutes, though, right? Like, we've added some files, we've edited some things, we've done some work. GitHub doesn't know that any of that has happened, right? As I said, you can make files, you can make changes locally, You can do commits locally. You can work locally. But Git and GitHub are going to require you to take some proactive steps to make sure that the things that you are interested in working on exist on GitHub and not just on your machine. Now, you do have to take some steps for this to happen. It's helpful that those steps are not overly burdensome. So here in the Git pane, it says your branch is ahead of origin master. That is essentially saying your branch, the branch that I have on my machine, is ahead of the one that exists on GitHub by 4 commits. The 4 commits of adding a template, adding basic plots, putting in the RProject and Git ignore file, and then editing the template. And so what I need to do is make sure that those changes get pushed. So I'm going to click push, and it's going to think for a minute. It's going to talk to the internet, and then it's going to say, okay, good work. And now I'm going to go back to my web browser and let's see what happens. So now a few things have happened. Now my most recent commit is 2 minutes ago. I've got a history of 5 commits. I'll open that so we can take a look at it. It's listing now all of the files that exist here. It's got the commit message that is most recent. The README file, and this can be helpful, the README file is showing both the title of the repo and also that text that we had seen, right? And I'll talk more about this in just a second. I can go back and take a look at these commits so I can see, all right, what happened initially. Here I added some RProject infrastructure. What happened when I added the template, R markdown file and thing. You can sort of scan through and see what has happened, right? So you can keep track of this process online using GitHub, right? And that's one of the reasons that GitHub turns out to be helpful, is that now I've got some changes, I've got some public way and some infrastructure for viewing the development process for this project. Now again, the main thing that I had to do for this to work, I did an awful lot of the work locally. I after creating that GitHub repository and cloning it, putting it on my machine, I was able to do data science. I did some R markdown stuff. I made some plots. I did all of that in RStudio on my machine. I kept track of what I was doing by making commits, and then I pushed those changes online. Okay. And if you're following along, I think this is one of those times you want to make sure that you can both create that local repository, you want to do some changes and make some commits, and then you want to confirm that you can push those commits online. One of the things that I'm going to take a look at next is the way that files get rendered, the way that files are viewed online. And so one of the things that I'm going to take a look at, let's see, basicplots.html. I'm going to click on this. And what this is going to show me is the actual HTML file that exists inside of this. And if you've never seen HTML, this is what it looks like. It's got start HTML, head of the file, meta, title, loading some scripts. It's doing a bunch of stuff. This is what HTML looks like, and it is unfortunately not what we would like to see. And so that's going to be at least a bit of a sticking point. Now, what I'm going to do instead, let me go back. I'm actually going to edit some files over here. So I'm going to take a look at this basicplots.rmarkdown, which is generating as output an HTML document. Now, the HTML document looks nice when it is rendered here. If you send somebody an HTML document, they can open this up and take a look at it. But as we just saw, it really doesn't look great as HTML. It doesn't look great as something that exists on GitHub. So what I'm going to do instead is a new output version. I'm going to output this to a GitHub document. Let me reknit this. Now, the formatting here is a little bit different. This is sort of what the viewer window looks like. The formatting here is a little bit different, but it's got the same kinds of elements. It's got the title, it's got the author, it's got the date, it's got all the text, it's showing the code, and it's including the figures. Okay. Now, there are a couple of things that have happened up here. In changing the output document or the output type from HTML to GitHub, if I go over here, I no longer have the HTML file, but I do have a .md file. So our markdown here has been modified, HTML has been deleted, MD has been added, and then there are some files that go along with this. And those 2 files are the figures that are included inside of this document. Okay, now there's a fair number of things that have changed here. So I'm going to go ahead and commit, and I'm going to say output type is HTML to GitHub. And we'll do plots here to be clear about this, and I'll commit this. And then just to be complete, I'm going to do the same thing with the template. I'll change this to GitHub document, and I'm going to knit this as well. And the same kinds of things show up. This has been modified, this has been deleted, and this has been added. And if I go to commit, you can actually see here in the template RMD, it says, here's the only line that has changed. Everything else in this document is the same. You've got a quick preview of what has actually changed. And this is template output is HTML to GitHub. I'm going to commit this. Now, again, those changes exist on my machine, but they don't exist online yet. And so either here, or I guess I'm going to close this, I'm going to click push, and it's going to talk to the internet and put these things online. And that's what I'm going to take a look at now. Let me find it. Here we go. So in my repository, let me refresh this. Now I've got 7 commits. I did the plots output type and the template output type, both from HTML to GitHub. And the main reason that this turns out to be useful is that now instead of clicking this and seeing HTML, I can click this and actually see something that gets rendered, right? So GitHub, in this GitHub format, in the GitHub document format, the reason that we're doing this is so that the result gets rendered in a way that people can read. It gets rendered in a way that you can send somebody to and say, this is my report, it's public. You don't have to worry so much about the formatting. You don't have to worry about sending an HTML or a docx. You don't have to worry about what format you're generating. You can just tell somebody, go to this repository and navigate through, and you'll be able to understand what I did. And so it's got the basic plots, it's got the code, it's got the plots here, it's got all the stuff that we might want to have. Okay, and the same is going to be true of. Went too far. The same is going to be true of the template document, simple document, section 1, section 10. Right, everything is now readable on GitHub, and that turns out to be very helpful. So generally speaking, there are a couple of output formats that I am most likely to use. I use HTML a lot if I know that what I'm going to produce is something where I want there to be some amount of interactivity, right? If you want to have a floating table of contents or a button that allows you to show or hide code, then HTML I think really works well. If I think what people are going to want to see is something in a GitHub repository, then a GitHub document works really well, because this is public and it's readable and it's easy to see in a way that a PDF sometimes isn't, or an HTML file certainly is not, right? This is going to be a useful output format. Now I'm also going to comment sort of briefly on the timing, the structure of the commits that you might make, right? So here I've made a lot of commits in large part to be clear about how this happens and why this happens, right? I want to get used to the commit and then periodically push workflow. I could have put these 2 commits together and said, I'm just updating the output type. I could have put these 2 commit together and said, I'm downloading some templates. Again, the frequency with which you want to commit depends on how big of a chunk you want to explain at a given time, right? I certainly would not want to go from initial commit to here with no commit messages. I want to know periodically what's been changing and why it's been changing. But you might not need quite this many commits. So it's I think a useful way of thinking about it is, how big of a chunk do you want to make sure gets explained in words? How big of a chunk of work do you think is going to be necessary for yourself 3 months from now, 6 months from now? Or if you sent this repository to somebody else, how much of a chunk would you need to explain that adequately to somebody else? And that's something you get better at understanding over time. My advice when you get started is commit more frequently than you think you need to. And if you find 3 months from now you've worked on a lot of projects and you say, oh, I didn't need that many commits, you can start sort of toning it down a little bit. You'll find that balance a little bit over time, but often the tendency is to commit not frequently enough. And so I encourage you to commit pretty often. I also generally recommend useful, informative commit messages. So here, this is enough for me to understand, roughly speaking, what happened in this commit. It's short. I can click on this and I can take a closer look at what has happened inside of this commit if I need to. But if I just want to understand what's going on in this, then this sequence is, I think, pretty informative. So you want your commit messages to be long enough to describe what's happening, but not so long that you really are burdened when you try to catch up on what's happened in the past. This is advice that I always give. It's advice that I follow myself the majority of times. Every now and then when you're working on a project, you just end up putting your commit messages as just a bunch of question marks because you don't really know what's going on. These things happen. Try to avoid it and give yourself some informative commit messages. And again, if you're following along at home, this is a good time to stop and make sure that you can create output that looks like a GitHub document and then view that output on GitHub in this way. What I'm going to do next is switch gears a little bit. And this next bit, I have to admit, is going to be just a tiny bit contrived, even more contrived than some of these videos often are. The reason that it's going to be a tiny bit contrived is that I'm going to try to demonstrate the process of collaborating with somebody else, but I'm going to do all of that collaboration sort of by myself. And so what I'm going to do as part of this is go to settings for this repository, and I want to manage access. And in managing access, I'm going to invite a collaborator. And the collaborator is going to be BST P8105. There is so I'm right now navigating this in my personal GitHub account, but we do have a course GitHub account, BST P8105. And I'm going to add this to the example repository. Now that has sent an invitation, and although you can't see it, that email account now has gotten a collaborative invite. And what I'm going to do on a separate computer is sort of do that collaborative bit, and I'm going to try in this screencast to show what collaboration looks like from my perspective, from the perspective of Jeff Goldsmith, when I am collaborating with BST P8105. Okay, so in the interim, in the last couple of seconds, couple of minutes, what I have done as BST P8105 is in my email account accepted the invitation to collaborate on this repository, and then I've gone ahead and I've made some changes. Now again, on this machine, on this screencast, I'm still Jeff Goldsmith, I'm still sort of seeing what I see. But on another computer, as BST P8105, I've started doing some collaboration. So I'm going to navigate back to this, and as Jeff Goldsmith, I'm going to take a look at this, and I'm going to say, oh, check it out, there's an additional commit from BST P8105. It looks like that commit messages update the README with information about files. I can navigate to this if I want a little bit more information and click and see what happens. It turns out that whoever this is, BST P8105, has added some information to the README, and it says, in addition to this being a first quick GitHub repo, it gives some description of the two documents that are here, a template R markdown with basic formatting and an R markdown with some plots. If I go back to the README, great, it's all here. I've got this example repo, I've got some additional description. There are now two contributors, me and somebody else, and everything is going smoothly. Now, again, as myself, if I come over here and I'm working on my part of things, I can take a look at what's happened. Let's see the README. Nothing's here yet. I haven't made any changes, but the changes that BST P8105 made are also not here. Now that, again, is because GitHub, in contrast to something like Dropbox, isn't going to take any action until you tell it to. It's not going to say, there's some update on GitHub, you should really bring that over here. It's going to wait until you say something specific. So BST P8105 became a collaborator, created a version of this repository on that machine, made some edits, committed those changes, pushed those changes to GitHub. And now it's up to me to make sure that I pull those changes before I start doing anything else. So I'm going to pull these changes, and it brings me forward in time. It adds this information to the README document, and now I've got a version that is consistent with what's on GitHub. And as long as me and my collaborator version of me are committing and pushing and pulling in a way that's reasonable, usually in an order that says I'm going to pull first and make sure that I have I'll commit first and make sure that all of my changes are stored. I'm going to pull to make sure that I haven't missed anything. If there are conflicts, I'm going to address those, probably by calling my collaborator or trying to figure out what the right way forward is. And then I'm going to push the most recent version online. So you sort of, when collaborating, need to be more careful about that commit and pull and push cycle. You need to make sure that there are open lines of communication, but that's roughly speaking how things are going to work. Now I can, over here, let's see in the basic plots, I've got a scatter plot of y versus x. I'm going to say, lastly, we show a histogram of y, of the y variable. And I'm just going to copy and paste this code. I need to update the GitHub code chunk, and I need to say what variable I want to have on the y-axis. And I'll save this and I'll knit it. And then in Git, I will update each of these things. I've modified the R Markdown and the GitHub version, the .md file, and I've added a new figure here. So I'll commit all of these things. Added y histogram to plot RMD, and I'll commit and I'll push. Okay. And now I can go over here to GitHub and double check what's happened. There are now 9 commits. You can see what has happened and when it's happened. All of these things are sort of happening in parallel. And it's possible, I guess I want to be clear, it's possible for me and a collaborator to work on things in parallel. That's not going to in and of itself create a problem. If the collaborator version of me is adding a new file or editing a template or even editing a different section of the same file that I'm editing, as long as we're not editing the same thing at the same time, the same lines of the same files at the same time, then we should be able to collaborate in this way relatively seamlessly. It does require at least some amount of coordination. It requires some amount of making sure that people are working on the project in the way that they're supposed to. I'm not in this screencast going to demonstrate what happens when you don't do that. Suffice it to say, if I and the collaborator version of me both edited the same thing at the same time, we would pretty quickly get an error that says you've got a conflict and you need to do something about that. And for today, what we need to be a lot more concerned about is just getting used to this idea of working with Git and working with GitHub and committing in this way. And so that is the main thing that I want to stress is the workflow that I'm now suggesting that you use if you are going to create a project. And this, I've stressed in the last few lectures, things like workflow, and I encourage you to adopt a single workflow. The thing that we have done today is when starting a new project, implement a GitHub repository and copy that GitHub repository onto your machine. Do data science in the same way that you normally would. Do stuff in R and in RStudio and using R Markdown, and periodically save those things using a commit to Git and push those things to GitHub so that the description is public, the changes are public, everything is stored in the cloud. You should, in general, do the same kinds of things in a workflow that I've stressed elsewhere. Your code should be clear and transparent. Everything should be reproducible. You should try as much as possible to make sure that everything relevant for a project is in the same place. The data, the code, the output, the drafts, other things that are relevant, all of that should be in that one place. The things that are different after this video are that you're going to be using Git and GitHub for version control. You're going to be using Git and GitHub to keep track of what's going on and what's changed over time. And with that, I'm going to go ahead and end this screencast. Thanks very much.